We're pleased now to welcome in Igor Lednev from University of Albany at the State University of New York, speaking here this week on vibrational spectroscopy and advanced statistics for detection and characterization of gunshot residue. Tell us, what kind of applications are there for vibrational spectroscopy in forensic chemistry?
Well, vibrational spectroscopy and Raman spectroscopy in particular has been known for many years as most selective spectroscopic technique. And if you add that it's non-destructive, it can be measured on a crime scene using portable instrument, it uses very small amount of material, you can understand that there is a lot of potential applications. And most recently, what happens is Raman spectroscopy started to be used in very different fields, starting from forensics and security and going into process control and medical diagnostics. And all this because technology advanced very significantly during the last decade or so. Lasers becomes very stable and relatively inexpensive, and digital cameras were developed, which we are using in common photography, but it makes Raman spectroscopy relatively inexpensive, absolutely reliable, and portable.
Why is this technique different, and why does it seem to be working a little bit better?
Well, as I said, Raman spectroscopy is very selective. It provides so-called vibrational signature of the material, which is a very specific identification of material. So we can use it for characterizing material, for detection of biological markers, for example, in the case of disease, or in our particular work, we characterized chemical composition of gunshot residue in order to link micro-sized gunshot residue particles which could be found at a crime scene to specific combination of gun and ammunition.
Wow, that's incredible. What have been some of the preliminary results from Raman and FTR data that's been collected?
Well, the most exciting and most promising result for us is the following. Together with New York State Police Crime Laboratory, we shoot 3 different guns. We collected gunshot residue particles and we characterize them with vibrational spectroscopy, both Raman and FTIR. And then we built statistical model which would allow us to differentiate particles based on guns or based on firearms which we used to create them. And then New York State Police fired those guns again for us. So we pick up new particles which we didn't use before for creating a model, and with 100% confidence we assign individual particles to specific gun which was used to generate them. Well, you may say that it's a very long process before we characterize every type of ammunition, every type of firearms in order to make identification. But even now we can be useful for law enforcement agencies, for example, in the following situation. You have a crime scene and you have a victim which was shot, and if it's from short distance, then victim always have gunshot residue. And police has a suspect, and the suspect has firearm and ammunition with him. So we can fire that gun under controlled conditions, characterize gunshot residue, and then tell if gunshot residue found at the crime scene can come from this gun. So we can make this at least elimination of gun and suspect in this case.
It's incredible. What do you hope to see will happen with all of this research?
Well, we already have a patent on this technology, and we are looking for collaboration with companies, instrumentation companies, in order to make a relatively inexpensive portable instrument as a package using our technology. And then, of course, we need validation of this new technology in some law enforcement agencies. And as I said, we are collaborating now with New York State Police. This project is supported by the National Institute of Justice, and we hope that in 2-3 years we will be ready for full validation of this technology.
It's fascinating, the work that you're doing. We appreciate you stopping by and sharing it a little bit with us.
Oh, it's my pleasure.
Thanks,
Thank
Igor.
you.
Enjoy the rest of the week.
Thank you, Amy.